Hello everyone, welcome back to the channel. It is 2024, the year of the Linux desktop, and you're still sitting there using the graphical user interface for some odd reason. Well, I put together a Linux CLI crash course just for you so that you can go from being a developer that knows nothing about the CLI to someone that can be proficient with pairing with your other engineers, know how to use the proper commands and their switches, and most importantly, know finally how to exit Vim. Enjoy. The first thing that we're going to talk about is terminology. Because as engineers, if we're not using the same language or the same terms and the same definitions for those terms, then we're going to kind of talk past each other and not be able to communicate effectively. So let's define some common terms that we're going to use when we talk about CLIs, right? Command line interfaces. And the first one is the command line interface itself. A command line interface is nothing more than a text-based interface that allows users to interact with a computer or some software by entering what we call commands. And this is in opposition to what we call a graphical user interface, or a GUI, where you kind of use a mouse and point and click against buttons and whatnot. In short, when someone says a command line interface or a CLI, they really just mean any interface that you use text to interact with a computer instead of like buttons and mouses and stuff like that, mice and stuff like that, mouses. The next term is the actual terminal. So a terminal is just a device or program through which the user enters data or commands for a computer system and also displays the received output of those commands. And that's kind of like a lot of words, right? That's kind of a lot there. Let's unpack that. Well, a terminal way back in the day was an actual physical device that you wheeled around from computer to computer, and you plugged it into that computer in order to send input to that computer and receive output, right? It was your display, so to speak. Nowadays, terminals are programs and they show you a CLI interface when they're opened. So let me show you what that means. If I open up a terminal app on my operating system here, so mind you, I'm running Linux, but if you're running Mac, you can open up a terminal app as well. And if you're running Windows, you can open up PowerShell, or you can open up, I think it's called like command line prompt or whatever they call their CLI tool. And this actual window here that I'm moving around, this is my terminal. It's not a device, right? It's not a hardware device that I have to wheel around anywhere. It's a program. So modern computers use programs now for terminals. And when you see a program as a terminal, we often call this a terminal emulator because it's emulating what a terminal hardware device would have done for us back in the day. Okay? And this just sits here and waits. It waits for me to input some text and it'll display text back to me as necessary. But a terminal in its own right is not so useful. Terminals need to run programs so that you can actually do things. And generally speaking, when you open up a terminal, it's going to run what we call a shell. Now, a shell is just a program that provides an interface between the user, which is me, and the operating system, which is Linux in this case. So the shell that I'm actually running here is called Bash, the born again shell. And it is going to be my kind of middleman between me and the operating system. Because me as the user, I don't actually know how to make a network request on the operating system or create a file. I need to send commands through my shell, and my shell will take those commands, go talk to the operating system on my behalf, and get them executed, right? So go create file. My shell says, great, I have the command. I will go to the operating system, create the file, come back to you with the result. That result will be displayed to you via the terminal. So you can kind of see that data flow. Now, when you're on the shell, it's just going to open up, it's going to sit here, and it's going to wait, right? We call this the command prompt that's just sitting here waiting for input. And you can see I can type random things, right? Or I can give it real commands. So that's the next term that we want to talk about is command. A command is just an instruction or signal that causes a computer to perform a particular task or operation. So I can type a valid command here called who am I? You'll notice this command's not actually executed, right? Nothing's actually run yet. It's still waiting for me to initiate that and say like, hey, execute this. And if you press enter, it'll actually execute this command and print the result back to you. So here I executed a command called who am I? The shell took that command, went to the operating system, said, hey, run this command for me, please. It ran it, got the output, and it printed the output back to me. And all this is to just print out like my username. Commands can take what we call parameters, And parameters are just values or variables that a command can accept. And I can't really define parameters without defining arguments as well. So I'll define that real quick. Arguments are just values or variables provided to a command when it's executed. And you might be saying like, hey, Matt, that's like the same thing, right? Yes and no. They're two sides to the same coin. Parameters are the documented values and variables that your command accepts, right? So if you write a function that accepts a number, that's your parameter to that function. Similarly, if I have a command here that accepts some sort of extra parameter, maybe it's like the file to operate on, right? So like touch creates a file if you want it to. It actually just updates file metadata, but regardless, touch will create a file and it needs you to pass a file to be created. That file would be a parameter, right? But when I actually write the command out and I pass it its parameter, we call that an argument, right? So the parameter is more of the definition side of like what this command or function can accept. And the argument is more of the runtime side saying, hey, I am running your command or function, passing it the arguments to fulfill the parameters that you ask for. Again, in like modern software and programming and computing, we kind of just call them parameters or arguments interchangeably, right? We don't really make a distinction so much. So we don't really get too pedantic there unless we need to, right? Unless as engineers, the problem that we're facing requires us to. So if you hear someone say parameters or arguments, they're meaning the same thing, just the values that you're passing to this command or this function or whatever you're running. Then we have what are called options. So options are a type of argument that is used to modify the behavior of a command. So let's give some examples. If I run the ls command, which just stands for list files, right? It lists the files and directories in the directory that I'm located. If I ran ls downloads, I just passed an argument to ls saying which location I want to list files in, right? There's nothing in my downloads folder, so I got nothing back. I can add an option to ls to change its behavior, right? So the option is just an argument that can modify the behavior of a command. So I'll just go ahead and pass an option called -l, and this changes ls to now print its output in a different way, a long listing. Flags are also another type of argument that you can use, and they're used to disable or enable features of a command. So you might be saying, hey Matt, isn't -l like a flag? Well, yes and no. People use these terms pretty interchangeably, so you got to be, understanding of that. But generally speaking, an option is where you're going to modify the behavior of a command, right? So in this case, I didn't turn on or off an additional feature of ls when I passed the -l like flag, and mind you, I'm calling it, right? I'm intermingling these terms too. But when I passed the -l option, I didn't enable or disable an ls feature. I just modified its behavior to print it in a different format. There are flags that you can pass to ls to turn on and off things. I don't know them all off the top of my head. So you can do like --help to see like, what sort of options and arguments that ls takes, right? And you can see it here. But I didn't actually do anything there. So I'll clear. And then the last term is switches, and it's just another term for options and flags. So parameters, arguments, options, flags, switches, so many terms to describe pretty much the same thing. If you hear any engineer talking about these things saying, hey, use the -l parameter or pass that option or pass another flag or, update your arguments, they're just talking about the same thing. And they're talking about what you actually pass to your commands. Now, to make this a little bit, kind of seal this up for you, I actually created a small program in C called argprinter. So I'll just show you the code real quick. All this does is it takes arguments and it prints them out one by one, right? If you look at any programming language, you're able to retrieve the arguments that was passed to whatever command you're writing. And they usually call them arguments in the programming language, which goes to show you that arguments are what you take, right? And parameters are kind of what you define. So I'm just going to run this real quick. So I'm going to run argprinter. And don't worry about the syntax here. I'm going to go over like what the // means. I'm going to go over all this. But let's run this command called argprinter, and you'll see that argprinter only received one arg, right? One argument, and it was the actual command itself. But I could have passed it more arguments. I could pass it like foo and bar. And you'll see that now my program has received 3 arguments: the command itself, one argument, and then a second argument. The command itself is always the first argument when you're running a command. And this is useful when you're doing some programming. And if you get into that, you'll understand why if you go down that path. But just to show you, again, kind of wrap it with a bow, you'll see here that this arg printer is printing out the arguments that I have passed to it. And to simulate like a full-fledged command, here's what I would look at. So I would say, like, let's say this is an option, right? This option can take its own argument to operate on. So let's say like opt, or let's say like log file equals, foo.yaml for like a log YAML file. And I'll do a flag that says, I don't know, dash verbose. That'll be a flag. And then I'll pass it an argument saying like, I messed up on verbose. Then I'll pass an argument saying like, sudo Mateo, like in all caps. If you look at this, and now this is just me simulating like a fictitious command that would take, this is the command. This would be an actual option. The option takes a value. This will be a flag. And then this will be an argument, right? Technically, all of these are arguments, but if we want to match these up to their definition, it'll be first argument, option, argument for the option, flag, and then an argument at the end. That's if you want to technically define all of these. But we don't really need to deal with that. We just call these whatever we want to call them, right? If I tend to say option or flag, you might want to say parameters or arguments. You might want to say switches. We're all talking about the same thing here. I just wanted you to see how this kind of works. So yeah, now we have all the terminology and we're speaking the same language here. Let's talk about how to work with files in Linux, right? Using the CLI. So if you run the pwd command, which is print working directory, it will print the directory that you're currently located in. And now you'll see this directory gets printed in the /home/sudo Mateo format. This is what we call an absolute path. Why do we know this is an absolute path? Because it begins with a leading slash. This leading slash is significant in Linux. It stands for the root of the file system. File systems in Linux are arranged in a upside down tree fashion with the root at the top and then the different directories and branches going downwards. If you're coming from the Windows world, you might be like, where's my C drive? Where's my D drive? We don't do drive letters here in Linux. Everything, even different disks and whatnot, all come under the same root file system. So reading this from left to right, it'll be the root of the file system, the home directory, a separator, and then the sudo Mateo directory. That's where I'm located. And if I bring up a GUI file browser for a second and show you side by side, that's where I am, right? I'm in my home directory. If I were to create a new folder in the UI and call it foobar, and I do ls to list files in my current directory, you will see the foobar directory is created, right? And I have this foo.txt file here, and you can see that in both sides. So I'm gonna go ahead and remove the foo directory, right? I'm gonna remove it from the UI and do ls. Notice, right, it's gone. And then I'm gonna go ahead and show you another command called rm for remove, and I'll remove the foo.txt file, and you'll see that that was gone. So I'm in the same location here on both my CLI and in the UI, right, the GUI. So we're gonna just be working with the CLI. I just want to show you like where I was in the file system. And if I change directories into, let's go into downloads, right? And I go into downloads here, like this folder's empty and the CLI says the same thing. So the next command I want to show you, and I'm going to get rid of the UI now. Next command I want to show you that I just did is cd, and that stands for change directory. So when I did cd downloads, I changed into the downloads directory. And that only worked because I was already in a directory that had a downloads directory underneath it. This is what we call a relative path because there's no leading slash in front of it, which means it's relative to whatever your current working directory is, which you can always find out by doing pwd. Okay, So let's clear the terminal. If you type clear, it'll just clear your buffer here and bring the prompt back to the top. If I do cd without any arguments, it brings me back to my home directory. And let's just take a look at the absolute and relative paths for a second. If I wanted to, I can cd into /temp, which is from the root file system, go into the temp directory. This is an absolute path. So now I'm in /temp, right? But if I wanted to cd into home sudo Mateo, notice I don't have a leading slash here. So this is going to be treated as a relative path. Since there is no such path, it'll say, wait, can't do that. There is nothing there. If I wanted to go back home, I could either type cd with no arguments, or I can type the absolute path of my home directory. That'll both bring me to the same location. And taking this one step further, let's go back into the projects Scratch CLI location for a second. List the files in here. Remember this arg printer that we had? I go ahead and run it for a second. And I told you that I was going to come back and talk about these /. The dot is a special symbol that means the current directory. This slash is treated as a directory separator. And then argprinter is the file that I want to run. So when I write /argprinter, I'm saying, hey, in this current directory, run a file or run a program called argprinter. And if I typoed that and said like /foo, there would be nothing there. It would say, hey, there is no file in this current directory. But let's say that I was way outside of this argprinter directory, right? Like let's go back home and I wanted to run argprinter. It'll say, wait, this command wasn't found. But what if I wanted to run this anyway? Well, I'd have to pass it the actual path to the entire location. So I can do home, sudo Mateo, project, Scratch, CLI, argprinter, and now I can run it, right? And since I'm already in the home sudo Mateo directory, right? I'm in that directory. I could have just did a relative path called projects, Scratch, CLI, argprinter. And that also would have worked. So you can start to see this absolute path and relative path and how they're important. Be careful when you're using one or the other. Absolute paths are really nice when you're working in like an automated fashion, like you're doing some programming and you want to be sure that no matter where you are in the file system, you are actually running the correct file or command. Relative paths are really nice when you're working in like your project, right? And you're in a certain directory and all your code is in there, your source code, and you're kind of just moving back and forth between files. It's really nice to use relative paths there. Always just keep in mind where you are on the file system. Cool. Let's move into talking more about like working with files and like creating them, deleting them, editing them. So let's talk about that. So I showed you pwd, I showed you ls to list the files that are in your current directory. I showed you cd, right? I can cd into downloads. And then if I cd, I can actually go back up, right? A directory. So one thing I didn't tell you before, a single dot is the current directory, but 2 dots is the parent directory. So when I do cd ... I move up a directory. So I just want to show you that. I can create new directories using mkdir, which is make directory. So let's make a directory called foo, ls, you see it there. And now I have a new directory. That's great, but let's make a file in there. So you can use the command touch to create a file. So if I say touch foo bar and I do ls foo, you'll see that there's a bar file inside of foo, and that's what my structure is looking like. If I wanted to remove this foo directory and all the files underneath it, I can do rm foo, but you'll see, hey, you can't use the rm command to remove a directory. You'd have to use the rmdir command. But if you try to use the rmdir command, rmdir only removes empty directories. What gives? Well, there's 2 things you can do here. You can either empty the directory first, so I can remove foo bar, and then I can rmdir foo, and now that's gone. Or let's make that again. Make dir foo, touch foo bar, or I can use special arguments to the rm command saying recursively, forcefully remove everything from foo underneath. And now those are gone as well. Now, this rmrf is a destructive command. Be careful what paths you pass to it. Be careful when you're using absolute paths and relative paths with this command because it's destructive, right? So everything you do in the CLI is destructive. And as soon as you press enter, you can't take it back. So just be careful when you're using these things. What if I wanted to make like multiple nested directories, right? Like foo, bar, baz. Like if I wanted to create this tree of directories. Well, mkdir, make directory, doesn't do that by default. You have to pass it an option to do that. And the option would be -p, which stands for make parent directories. And now all of those directories got created. And if I ls foo, there's bar inside. If I ls foo bar, there's baz inside. And if I ls foo bar baz, there's nothing inside. Okay, so I'm gonna go ahead and remove all of that because I don't really need it. And now we're clean. What about not just, creating directories and files and removing them? What about like copying files around and like moving files around? Well, let's create a file. So I'm going to run this echo command, and echo just prints out text to the screen, right? I'm going to send that output of that command into a new file called like foo.txt. And if you see now, I have foo.txt here. I can use what's called the cat command, that stands for concatenate, and I can cat out the file contents. So I have a new file called foo.txt. I can use a command called copy, cp, and I can copy foo.txt to bar.txt. Now I have foo and bar, and they both actually have the same text, right? Now, what if I didn't want to copy a file? What if I wanted to move it, right? So if I said, oops, it wasn't actually supposed to be called bar, it was supposed to be called baz. So I'll move bar.txt to baz.txt and then ls. You'll notice that foo is still there. We didn't touch that, but bar has been moved to baz. So you can use copy and you can use move to copy and move files around. What about editing files, right? Like I'm not going to use echo to like echo like long texts, right, to my files. I'm not going to do that. And you can press Control C to like cancel what you're doing on the terminal. I'm not gonna do echo to like work with large files and whatnot. Well, luckily there's a better way. Your command prompt, right? Your CLI comes with different text-based editors that you can use. One is usually called Nano. That's a pretty like popular editor now because it's pretty easy to use, but it's not super featureful. But if you type Nano just with no arguments, you're put into a text editor and you can say hello from Nano, right? You can start typing and it'll work, excuse me. And in here, it looks good. I'm typing, I'm writing things. And if I want to save this, if I wanted to get out of here, well, all of the commands that you can use to get out of this or to do things with this editor are on the bottom. That little caret symbol just means command or control if you're on a Windows machine. So if I hit Control X, right, it'll ask me to save modified buffer, hit yes. And then it says, what file do you want to write this to? And I'll write this to foo.txt. And it says, hey, foo.txt already existed. Do you want to overwrite it? Yes, I do. Press Y. And now I've just edited a file via the text, CLI command prompt. If I now cat that foo.txt, my contents are there. In addition to Nano, there's something called Vim. Vim is a pretty fun editor to use. It's the editor that I use primarily, but it's kind of complicated to use at first because it's a different way of editing. It's a modal editor, meaning it has different modes that you can use. So when you do Vim and like if you give it a file name to edit, you'll see that you can start seeing the text, but you can't actually type anything yet until you hit the I key to go into insert mode. And now I can start typing and changing things. But to get out of this, to say like I'm done and save the file, I have to do escape, WQ for write, quit, hit enter, and now I'm out. It's a more complicated editor, but Vim VI specifically is like its older brother essentially, the older command VI. They're pretty ubiquitous. Odds are on any Linux system that you connect to, VI will be there, or Vim. More recently, you're starting to see Nano show up because, people have complained for a while that Vim is too hard to use and I can't exit it and da-da-da-da. So you'll see those commands as well. But what I'm trying to say is learn a text-based editor and use it so that way you're comfortable with editing files in the command line. Cool, to recap, we did pwd, right? We did ls, we did cd, we did rm, we did make dir, we did cp, mv for move, right? We did all of these commands. We did echo. I'll do echo sudo Mateo. We did cat. Cat, if you run it with no arguments, it'll wait for you to type some stuff and then hit Control D to like send it. But I'll hit Control C to cancel. We did clear. I'll show you again. We did nano. We did vim. So we learned how to work with files. So now you should be pretty comfortable moving around the file system and working with files and such. And now it shouldn't be so like worrisome, right? You shouldn't be so overwhelmed. Play with this, move around the file system, create files in your machine, and get comfortable with it. Because being proficient at moving around the file system and like editing files, looking at their contents, moving them around, that's really important if you're going to be working with like systems on the command line interface. Okay, let's talk about how the shell finds commands. So we've been typing commands just like this, right? pwd, who am I? We even use like the absolute path to one of the commands that the programs that I wrote, the arg printer, and we ran a command with like its absolute path. But running a command like this, right, with its absolute path all the time is impractical. You would need to know the location of every command on your machine in order to run it, right? How is the shell able to find commands like this, like who am I, no matter where I am, right? If I cd'd into temp and I ran who am I, it still works. If I go back home and I ran who am I, it still works. How is the shell able to find this command and know that like I can run it? Well, it uses what's called the path. So path is an environment variable, and we'll talk about environment variables in a little bit, but it's an environment variable that tells the shell where to find commands. Now I'm going to do printf path. We'll cover this again more later. And I want to show you like the contents of the path environment variable. The path environment variable is a colon delimited list of directories for the shell to search to find commands. So you see here I have /home sudo Mateo local bin is one directory to search, /home sudo Mateo bin another one, user local bin, user local sbin, user bin, and user sbin. So these directories are what are searched when you run a command. And they're searched from left to right, right? So if I run the command pwd, it'll search in this location first. If it finds it, it'll execute it, and it's done. If it does not find it, it'll move to the next location. It'll search in there. If it finds it, it'll execute it, it's done. If it does not find it, it'll move to the next location, and so on and so forth. If it exhausts all of these locations and it still hasn't found the command, like if I run foo, it'll print out command not found. So how can I add a command to this location? Right, I have two options. So if I wanted to run my arg printer command just like this, no matter where I was, I have two options. I could either add it to one of these locations on path, right? Or I can update path to point to the location of where arg printer is actually located, right? And I'm going to do the former because I have locations where I dump like arbitrary commands for my use case, right? I have like this location here. So I'm going to go ahead and copy arg printer there. So I'll copy projects, scratch, CLI, arg printer, and I'm going to copy it to the /home sudo Mateo .local bin. Now, this is the first time you're seeing a file that begins with the dot, and I know I told you that dot stands for current working directory, but in this case, when a file name starts with a dot, it is called a hidden file, right? We're not really going to cover that. You can go research that on your own, but this is a hidden file or a hidden directory. So I'm going to copy the arg printer command into that location, and now I can run arg printer, and boom, it works. It works no matter where I am, right? If I cd'd into temp, since my path is still the same, since my path variable, right, my path environment variable is still the same, so I'll just show you that real quick. I can run arg printer, and everyone's happy. Okay, and that's how it works. That's literally how it is to add commands to the system and make sure that people can use them. Now, that's how it works for majority of commands. I'll go back home for a second. And if you wanted to ever find out where command is, there is a which command, which and you give it the command to find. So I do which pwd, it'll say, hey, I found that in this location. I can do which arg printer, and it'll say, hey, I found that in this location. And you might be wondering what this little tilde here is. This tilde is just a shorthand for your home directory, a user's home directory. This command, this which command is really nice to see where command is located on your file system. But it might not actually find everything. So if I did something like which echo, or like which cat, or like which, bash, right? You're seeing these things, but some commands are actually built into the shell. I don't know if I can find one of them off the top of my head, but if you ever run the which command and it says like it's a built-in, it means that it's built into the shell itself. It transcends the path essentially, right? It's before all of that. So if you ever see like, wait, I saw there's a built-in there, well, that just means it's built into your shell. So just keep that in mind. Yeah, and that's how you find where commands are located on your system and how the shell actually finds them and runs them. So feel free to play with path. Try not to permanently like overwrite the default values in path unless you know what you're doing, because you can leave yourself in a situation where like if I emptied out path completely, I would not be able to run any command without knowing its exact absolute path, right? So don't do that. Feel free to add to your path as necessary, but try not to remove like the default values that are on there unless you really know what you're doing. Read up on it, research it, and you'll see how to use it. Okay, let's talk about aliases. Now, it gets a little cumbersome to have to run commands that have a long name, like argprinter, right? My argprinter command, it's kind of a little long. To type that out every single time gets a little annoying. You can actually create an alias to kind of shorten that command, and you can say alias, I'll say ap equals argprinter. So if I do this, I created an alias for that command. So now if I just run ap, now I have an alias for that argprinter command. So I don't have to do as much typing. And if you ever worked with somebody before and you saw like them use a command line interface, you might see them do like, git as a command, or they might have shortened that to G, right? They're just using aliases to do that. So if you don't want to type a command like that's super long, you can use aliases as well. I can actually create another alias called ap foo, and I can not just alias the command that it runs, but also the arguments. So I'll do foo bar baz here. And now if I run ap, I get argprinter, but if I run ap foo, I get foo bar baz. So you can create these aliases to hold more complex commands that you've been running in a shorter fashion, which is actually pretty nice to do that. So create your own aliases as you see fit, but remember not to overwrite existing commands with an alias. That's bad, right? You don't want to ever like overwrite a built-in like primarily used command like rm or cp. You don't want to really alias them and overwrite them, because you can get into situations where you have unexpected behavior as you move across different systems. And that's aliasing. Let's talk about the shell history. So as I type commands like pwd or who am I can actually hit the up arrow to go back to previous commands that I've actually executed, and the down arrow to go forward. So if I ran a super long command like, arg printer foo bar baz sudo mateo is the best ever exclamation point. If I ran a long command like this, I don't want to have to retype this command again if I want to like add a new thing to it. I could just hit the up arrow and then edit, LOL at the end and run it again. So use the up arrows to go up, back through your history, and down arrow to go back forward through your history. Really, really, really fun to do those things. In addition to just the up and down arrows, you also have the history command. So if you type history, which I obviously can't spell, you'll see that it prints out the history of the commands that you've ran. So you see, if I go back here, like the last command I ran was history, then I ran clear, then I ran argprinter, and and so on and so forth. And you can see all the commands that I ran in my history. It goes back as far as you set it. So if you want to like change how many commands are held in the history, you can research that for your shell and update it. If you wanted to rerun a command in your history with this number here, you can do, let me clear this for a second. So I want to rerun the command 486, right? So I'll clear and I can do bang 4, 8, and 6, and then it will rerun that command in the history. Really, really cool. Similarly, if I ran argprinter foo bar baz, and I just ran that command, and I wanted to run it again without typing it, I can do bang bang. That'll run the command again, right? Bang bang. We'll just run the previously executed command, or I could have just hit the up arrow and enter. But bang bang is really nice because it's a pretty shorthand if you don't want to type things out. In addition to just up arrows and searching through history like that, you can actually hit Control R, and this will do a reverse case insensitive search. That's what the reverse I search means, through your history. So now I can start typing like arg printer, and you'll see that it'll reverse search through my history. If I keep hitting Control R, I'll keep going back into that history. And that's pretty cool too. So that's a really good way to like reverse search through your history. Very, very, very useful. One of the last ones I want to show you about history is, let's say you typed a command like argprinter foo, right? Or even like a super, super long command. So argprinter foo bar baz, sudo Mateo is the best. This is really long, right? Sudo Mateo again. Let's say you ran that command, and now you have this super long command here, but you wanted to just change up something about the command, and you wanted to use the last element, right? The last word of that command. You can do escape dot to just get the last word from the previous command. And if you keep typing escape dot, you'll keep getting the last word of the last command in the history. And that's like super important if you wanted to change the command you wanted to use with that last argument. So if I wanted to do like arg printer, v2, if I ever had a v2 command and I wanted to run that against sudo Mateo, I wouldn't have to like edit this whole command. I can just do arg printer v2 escape dot, and then boom, now it's operating on sudo Mateo. So that's another really nice thing to do. Really useful when you're running like different options of commands with the same last argument, right? Maybe your last argument is super long, like a URL or something that you're working with, and you want to just keep reusing that. So yeah, play around with your history. It's really powerful to get good at searching through your history. So play around with it, research it, and hone your skills. Let's talk about environment variables. Environment variables are really useful in order to use your shell effectively. We saw one, right? We saw one before. We saw the path environment variable. And we used the printf command to print out the path environment variable. Now, environment variables are variables that are set in your shell's environment, meaning no matter what command you run, so if I did argprinter again, this argprinter command, even though you don't see it, was passed all of my environment variables into that argprinter command. So if I wrote extra logic inside of that argprinter command to print not just arguments, but environment variables, it would have seen this path environment variable. Every command you execute gets a copy of the environment variables from your shell. How can I see all of the environment variables that are currently exported in my shell? I can use the print env command, and it'll print out all of my environment variables. See, I have shell, session manager, color turn, all of this stuff is in my environment variables. And some of these environment variables are used by different programs for different things, right? Like we already looked at the path environment variable, which you can see looking through this with my eyes, right here, down here. Here's the path that's used by your shell to find where commands are. There's other ones. The current shell that I'm running is there. We have the history size, how many commands it's going to keep in your history, right? You have the current directory that I'm in. You have the default editor that you want to use. All of these environment variables are there. My home directory, my username, the locale language that I want to use. All of these are exported as environment variables. That way, the programs that you run in your shell can make use of them to do things for you. If you want to export your own environment variable, you can use the export command and give it a name and a value. So I'll do foo equals bar. And now I have exported that foo environment variable with the value bar, and it is there for my liking, right? So I did print env again for foo. Now it's there. But if I wanted to do a completely different environment variable like baz, you'll see that there is no such environment variable baz there. Knowing how to export environment variables is super useful because you'll use this for when you're running commands, you'll use this for like exporting your API key as an environment variable. That way you don't print it to the screen and like you get hacked, but the commands can still make use of it and use those environment variables. Now, I'm not really going to cover variables as a general topic in this crash course, but variables are important in the shell and you should know how to use them primarily when you're shell scripting. If you're just on the command line interface like this and just running commands, variables are not as important in the day-to-day. But if you want to learn more about environment variables and shell variables themselves, definitely go research that a little bit more. But knowing how to export environment variables and even unexport them, right? Unset them. So you can do something like this, unset foo. And now if I print env for foo, it's gone. So knowing how to export them and to unset them is important. And keep in mind, the syntax for that varies depending on what shell you're using. Okay, let's talk about a kind of complicated subject at first, but once you understand it, it clicks pretty well. Let's talk about the standard streams. And I'm not talking about like Twitch streams or whatever. I'm talking about streams of data. So your shell, when you start your shell, right, and you open up your terminal and the shell started, it is given access to 3 different standard streams of data: standard in, standard out, and standard error. These 3 streams of data are used for input and output. The standard in stream is used to take input from you, the user. So as I type things, I write who am I. This who am I is coming in to my shell through the standard in stream of data. And this sudo Mateo text is being output through the standard out stream of data. And then there's a third stream called standard error, which is usually used to print out errors from programs. I actually have a program here that I wrote again, and this one is now called streams, and I'll show you the code for it for a second. Don't even ask me why I wrote all this in C. I just did. I don't know why. I was gonna do Go, I was gonna do Rust. I was like, I'll just write it in C real quick. It's 2 lines. So this program prints out my username, right? Username sudo Mateo, and it also prints out could not retrieve password. But it prints my username information on standard out and my error information on standard error. So let's go ahead and run this for a sec. Let's run streams, and you'll see that my terminal has shown me both standard out and standard error. Now, I have no idea looking at this that this is standard out and this is standard error, right? Like to me, it just looks like text to the screen. But if I actually ran this, you can actually redirect standard out or standard error to different locations. So I can do something pretty cool like this. I can do streams, the greater than symbol, to redirect standard out. And remember, this is how we used it we used this symbol with echo before to echo text into a file. But I can do streams and then redirect standard out to a file called std out, right? And this file could be called anything. I'll just call it like foo, std out. Okay. And you'll see that the username text line did not print to my terminal anymore, but the error text line did. That's because this greater than symbol, this right angle bracket, only redirects standard out to the location. Now, if I look, I have a new file called foo standard out. If I catted it out, there's my standard out stream. Similarly, I could have, let's get rid of that foo for a second. Similarly, I could have also ran this command, but instead of redirecting standard out, I can redirect standard error. And that would be with the 2 in front of the angle bracket. Now, if I run this command, you'll see that my terminal has received the standard out, but that foo, and I should have called that standard error, so I'll update that real quick. And now my foo standard error file has the standard out error message. I could have also, so I'm going to remove both of the foo standard out and the foo standard error. I could have also redirected both of it. So I can do streams ampersand, the right angle bracket, foo both, and now nothing was printed to my terminal, but foo both has standard out and standard error. And notice something and I'm glad this happened because I really want to show you this. Notice something very important here. Notice the ordering in which this entered my file. I'll remind you for a second. If I look at the C code for a second, notice what happens first. The username is printed first, and then the error is printed. However, when I redirected my output to this foo both file, the error was printed first and the username was printed second. You would expect that to be flipped, right? Based on the code. That's a really cool, I'm super glad this happened because this is a really cool thing to show you. And this is something that's difficult for newer engineers to wrap their head around at first. Even though in the code, the username was printed first and then the error was printed, when I redirected the file streams, right, standard out and standard error to this file, it was non-deterministic which stream actually got permission to write to the file from the operating system first, right? So I did redirect both of those streams, and both the data was sent to standard out and standard error streams. And as it was redirected to this foo.both file, the actual Linux kernel, the Linux operating system, received both standard out and standard error, and there's a non-deterministic ordering of which one actually gets to write to the file first, right? It's called concurrency, right? This standard out stream and this standard error stream are both being written to concurrently. There's no guarantee of ordering in that location, right? In that situation, it's whoever gets there first wins. If I run the streams command with the redirection like this 1,000 times, I might actually get different results each time, right? Just keep that in mind, because a lot of people, they look at this and they're like, oh, this always has to come first. Not when you're redirecting output like that, because now you've put it into the hands of the kernel of the operating system, and it gets to make its scheduling decisions for itself. So pretty cool. I'm really glad that happened. Sorry, nerded out there a little bit. One other thing I wanted to show you though, with regard to these streams, is redirecting standard in. So for example, if you echo something, right? If you echo, let's see what I have here. I have the foo both. If I were to cat a file, I can actually cat foo both. Oops, sorry, that has to be a command. My apologies there. Foo both. I didn't mean to put the colon there. That's something I want to show you later. If I were to actually redirect standard input, so you notice, remember when we run cat and it just sits there waiting for you to type something until you like press Control C? You can actually tell cat to read from standard input. So now if I do this less than operator and give it a file name, I'm telling cat, hey, when you run cat, connect this file called foo both. I don't know why I put bath. Connect this file to the cat command. Cat will read the input there and cat it out, right? So that's how you redirect standard in from a different source. Normally, standard in is your keyboard, right? What I'm typing here. But if you use the less than symbol here, you can make standard in a different source for the command that you're running. Last thing I want to show you real quick is, again, let's run streams. You'll see that streams has, ran standard out, standard error. Let's redirect the output again to foo both. Let's cat out foo both again, and you'll see that it's there. And every time I run this and I cat it out, it's overwriting the foo both file, right? So even though this is the same content, it's each invocation of my streams program is overwriting this file. If I wanted to append, you just change the single greater than symbol or single right angle bracket to double. And this is now the append redirection. So now if I run this a few times, you'll see that no longer will I just get the 2 lines, it'll append to the file each time. This is very useful if you're running programs and you want to keep like a running tally of like the output of it. So that's everything for streams. Again, if you have any questions, ask and keep researching them on your own as well to further your knowledge. Now that we know about streams, let's talk about pipes. So when you are running commands, you get output on the screen, right? Like, so let's run the printenv command. The printenv command outputs all my environment variables, but it does so in a non-deterministic order, right? Like, this is not alphabetical order to me, so it makes it hard for me to scan this output and find out like what I want. If I wanted to do something with the output of printenv, I could have like written it to a file, right? I can call it like out.txt, and then I could have like used nano or something, and I could have like opened a file called like, you know, out.txt, and I can start looking at this output here. And I can do this, right? This is fine, but this is kind of cumbersome. What if I wanted to take the output of printenv and do more processing with it first before outputting it further? Well, that's where pipes come in. So pipes is just a vertical bar in Linux, right? So pipes take a command on both sides. So you have printenv on the left, and I'll pipe this to sort on the right. What's happening here is the standard out of printenv is getting connected to or piped to the standard input of the sort command. So output into input. And then the sort command runs and then outputs to the terminal. Since it's the last command in this pipeline, its output goes to the terminal. Let's see what happens. So if I pipe that out now, instead of the printf command output being all out of order, it was piped to the sort command. The sort command ordered it alphabetically and then wrote the result to the terminal. Pipes are super powerful. So you can build up pretty complex pipelines using pipes. So I can do something even further. I can do printenv. I don't have to stop at just one pipe, right? I can do printenv grep for sudo Mateo. Grep is just a way to find text and then sort that. So now I've grepped for all lines that contain sudo Mateo, and then I sorted it. And you can use pipes to create these complex command pipelines consisting of all these smaller like single use commands. Unix has what's called the like Unix philosophy, where like do one thing and do one thing well, right? Single use principles essentially. And the printenv command is really good at printing the environment, right? It doesn't sort data, it doesn't do anything. The grep command is really good at finding text. It doesn't do anything else besides find text. The sort command is really good at sorting. It doesn't do anything else. But when you combine those with different, using pipes in different orders, you can do the more complex scenarios that you've been wanting to do. A really commonly used pipe command, or should I say, a really commonly used command when you're using pipes is the less command. So if I do printenv and pipe it to less is what we call a pager. It views the output one page at a time. So if I hit enter here, you'll see that I'm put into a pager, and I can use the arrow keys to go up and down here in this page, right? And see different things about this data. I'm now viewing the data page by page, and I can hit the space bar to go down by a page, hit the B key to go back by a page. But now I'm viewing this data one page at a time, which is really useful when you're looking at like thousands of lines of logs. And if you didn't want to write it to the disk and you wanted to just look at it live real quick, you can pipe it to something like this, like less. Hit Q to get out of that. I just wanted to show you that because if you see someone that like runs a command and then pipes it to less, all they're doing is just paging it so they can view it by page and do some other things too, like find inside of that page. But you can research less to find out more about that. Now that we know how to use pipes, let's not just use pipes to pipe commands together, but let's start transforming the data that we're working with, right? So again, I'm going to use that printenv example here. So printenv, we have the ability here to like see all the environment variables for our shell, right? And we saw how we can do printenv piping it to sort, right? And do that, or even better, printenv and piping it to grep sudo Mateo to like grep just for I'll do that again up here, and grep just for text that has sudo Mateo, right? But what if I wanted to transform the text that I'm messing with, right? There's different commands that I can use to not only find text, but also like transform it. For example, there's a cut command. The cut command takes a delimiter. So I'm going to say the equal sign is my delimiter, and then it takes a field of what you want to print from that broken up delimiter. And if I say I want to print field 1, let's look at what this does for a second. It's going to give us all the environment variable names, right? Just the left side of the equal sign. So what I did here is, let me bring that back to the top. I ran printf. We know printf is just a bunch of like key equals value pairs. I cut it using the equal sign as the delimiter and getting field 1, so the first field before the cut, and now I'm transforming this data. It's really, really cool. So now I can build this up over time, and I can even go further and pipe this to sort, and now I have just a sorted list of all the environment variables, just their variable names, right? Not the values anymore. I can take that even a step further, right? So I can do print env, and we saw how we can grep for sudo Mateo, and it would give me all the environment variables whose value, all the lines that have sudo Mateo in them. What if I didn't want sudo Mateo there? What if I wanted to transform this data? I can use what's called sed, which is a stream editor, and I can do a substitution. So I can substitute sudo Mateo for foobar, right? And the syntax here is the sed command. S stands for substitute. / begins your find side of the substitute. So I want to find sudo Mateo. The next / is a delimiter that starts the replace side, right? So now I want to replace sudo Mateo with foobar. And then the last / is just like I'm done with my substitution logic. If I do this now, you'll see that these sudo Mateo lines have transformed into foobar. So you can see how I can use these pipes not only to build up more complex commands, but I can start transforming the data, right? It's pretty interesting. So now you have the tools you need to look at data on the command line and send it to a file, send it to a pager, pipe it together and process it with different commands, transform the data with different commands. Research these commands, right? Sed, cut, grep, research these commands and see how it can be useful for you. There's even a command called JQ, which is a JSON processor on the command line. And it gives you a really nice example here, which I will just copy for a quick second and paste it in here. And you'll notice that if I take something and if I take valid JSON data and pipe it to JQ, I can print that JSON out pretty. If I had more complex JSON like bar, right, equals, sudo Mateo, and hit it to JQ, I get the prettified JSON. I can also use JQ to just get the bar key from that. And now I get sudo Mateo. So no matter what format of data you have, odds are there's a command out there that you can use. And with some pipe logic, you can build up a really nice pipeline there. And then going one step further, since it's a text-based command to process that data, you can save that in your, run books or wherever you have. And now you can do that again and again and again. Imagine trying to do that with a point and click GUI UI. You'll never remember how to repeat that ever again. But since it's a text-based command and a pipeline, you just save it. Let's talk about shell expansions. Now, shell expansions are a little bit more of an intermediate advanced topic, I would say, but I wanted to show you them because if you're ever working with other engineers and they're using them, I didn't want you to be left behind while they're using them and not explaining it to you. So shell expansions are an interesting concept. To demonstrate them, let's create a few files real quick. So let's create, this is from foo, and then put that into a file called foo.txt. Let's do echo, this is from bar, and put that into a file called bar.txt. So now I have foo.txt and bar.txt. And I can cat them both out, right? Foo and bar. And this is great. This is from foo, this is from bar. But you'll notice that I have to add these as arguments to the cat command. And that's fine. But what if the arguments that I want to add to this come from a more dynamic source, right? How could I expand these arguments and pass them to cat more dynamically? That's where shell expansion comes in. Shell expansion says you can use the $ and open and close parentheses, and you can run a command in here. So if I did ls, you'll see every single output from ls gets expanded in this location here. So it's as if I ran cat, bar.txt, desktop, documents, downloads, et cetera, et cetera, et cetera. It's as if I typed all of that out on the command line with cat. But I didn't. I used a dynamic source like ls in order to read all of those directories and files. I can take this one step further. I can do cat and do a shell expansion for ls and then grep just anything that's a text file. So grep for like .txt. And now it's as if I typed cat foo.txt and bar.txt. But I didn't have to type these manually. I used a shell expansion to expand to that for me. This is really, really useful and powerful stuff because you can start building up more complex commands with pipes and shell expansions. So it's kind of like nested commands inside of commands. And it gives you an ability to have that more dynamic source when you want to work with commands. Because I could not do this. I couldn't do ls, grep, txt, and pipe to cat. I can't do that. Notice how it prints the file name, not the file content. So shell expansions are another good way to run a command and whatever its output is, expand it right there in line for whatever command you're using. Again, a little bit more of an advanced or intermediate thing, I would say, but I wanted to show you this because a very, very common use case of this is when you're working with like containerization platforms. So you can do something like this, like podman ps to show me containers that I have. And then if I wanted to remove containers, I would do podman rm. And then inside here, you would do podman ps-q to like get the container IDs. Q is just quiet. And this is a shell expansion, right? This is like a super common thing for people to do. And you can, if you're not using podman, you'd be using something like Docker. But you will probably see this in the wild if you're working with containers, something like this. And that's all that's happening. It's as if, imagine if I had a few Docker IDs here, it's as if I typed them all one by one here, right? Like ID1, ID2, ID3, but I don't have to type it manually. I can do it with a dynamic shell expansion. Like pretty cool stuff there. So now you have all the tools you need to with pipes and shell expansions, you have the tools you need to now really build up those complex commands and transform your data pretty powerfully. And there you have it. That's the Linux CLI crash course. Let me know what you like and didn't like in the comments. If there's something that I was missing that you really wanted me to dive into a little bit more, let me know. And we can always possibly do that in a future video. Otherwise, stay with the CLI. You're going to love it. I promise you, there will be a time where you're just like, no more GUIs for me. See you in the next one.